We are reviewing Chapter 6 and creating our graphic organizer. And this chapter is Solving and Graphing Linear Inequalities. Be sure your name is on the front. Our first topic was solving and graphing inequalities using the basic operations: addition, subtraction, multiplication, and division. So as we progress down this panel, just go to the back side of your rectangle and then the front side and so on. Let's start with addition and subtraction, properties of inequality. So if x plus a is less than b, and we are solving for x, what will we do to get x isolated? Lindsay?
Subtract a from both sides.
She says subtract a from both sides. Does that change our sign?
No.
No. So we can show that by simply subtracting a from both sides. We usually do it underneath it, right? Because the inequality is written and we just do it underneath. It can also be shown horizontal like this. Subtracting a, both sides. And now the left side has plus a minus a. And so what else is left on the left side?
X.
Just x. So we have x alone is less than, who can finish it?
B minus A.
B minus a. Okay? So this is the rule. When we subtract the same term from both sides of an inequality, we have an equivalent inequality. Right? We have an equivalent inequality. We just changed something a little bit. We transformed it a little bit. Okay? We could write another rule like this for subtraction, but instead of writing it in the form of a rule, I'm just going to give it to you as an example. So try this one. M minus 9 is greater than or equal to negative 4. So this, we're going to solve for m. What will we do to both sides to solve for m? Casey?
Add 9.
Good. So he says add 9, and because we had subtraction, the inverse operation now is addition. Adding 9 to both sides, we still have an equivalent inequality. Okay? And now we have m is, did that change our sign?
No.
So addition and subtraction don't change the sign, you're right. And m is greater than or equal to 5. Okay? And then the second thing we did was graphed it. So let's go graph this. And just make a quick little number line. And we need to see 5, so I'm zooming in on that section of the number line. And what do you have to ask yourself when graphing this?
Solid.
She's saying solid or open, right? And what will this one be?
Solid.
Solid endpoint at 5, because 5 is greater than or equal to 5. And then which direction will the ray point?
To the right.
Greater than, this way. Okay, greater than is to the right on a standard number line. Next panel, let's make a note of how the endpoints can differ. If we have less than or equal to, or greater than or equal to, what does the point look like? Ray? This will be solid, good, or a closed dot. And then if we have less than or greater than, the dot will be what, Ray? We call it open dot. This particular section has the most information as you're going down in your graphic organizer. So before we actually write what goes on here with multiplication and division, let's try this example. So the box is covering some information if you want to leave a little space. Negative 3x is greater than 27. So, Hannah, what shall we do to solve for x? And what do you want to tell us now? So she did what with a sign? Switched it. Why did you switch a sign? When we are dividing or multiplying by a negative, we have to remember to switch signs. Okay, we have two special situations. It seems like every section that we covered, there are some special challenging inequalities that pop up, and here are two. So leave a little space, and then let's try this sample. What happens when we solve for t in this example? So what would the first step be in solving here, Bella?
Distribute it.
Good. So I'm going to try to move that up a little bit. we're distributing, so you end up with what?
8t and
Minus 8 is greater than negative 8 plus 8t. And then what would a person probably do now?
isolate
So how'd you do that?
you would add 8 to the opposite side.
So she wants to add 8 to both sides. Adding 8, I'm trying to make space here. That's an 8. And we have 8t is greater than 0, I'm sorry, 0 plus 8t. 0, what's 0 plus 8t? 8t is greater than 8t. And then what might a person do? Would you divide by 8? Would you subtract 8t from both sides? Could we subtract 8t from both sides? If we subtract 8t from both sides, we end up with 0 is greater than 0. Is this true? No, this is not true. I mean, if there was an equal sign beneath that inequality, it would be true. But this is not true. So how many solutions are there to this inequality? None. There is nothing that will make it work. We sometimes have basically a false statement. There's a no solution inequality. Okay? And then the second thing that we could have is this type of thing. I'm covering the answer, basically. So leave a little space. And let's try this one. Okay? So it says 14 plus 2t is less than 16 plus 2t. So what might a person do to solve this one, Anthony?
Subtract 14.
Okay, a person might subtract 14. So you would end up with 2t is less than 2 plus 2t? Okay, and then what would the person do?
We'll subtract 2t.
He's trying to move the t's together, so subtract 2t. But when he does, he gets this. 0 is less than 2. And the t's are gone. And is 0 less than 2?
Yes.
0 is less than 2. So how many solutions are there to this inequality? Infinite. So if you graph that, it would be a line that goes both ways, a solid line that goes both ways. So underneath the pink box, we have infinite solutions. Solution all real numbers to this one, or infinite solutions as we wrote it in our homework. So if we look at the original red inequality, 14 plus a number is always going to be less than 16 plus that same number, right? And you can substitute anything for t, and this is always going to be a true statement for it, right? Number 2, the second thing we did was solved and graphed. We weren't doing linear inequalities yet. We were doing what? Anybody remember the word? It begins with a C. Compound, good. Compound inequalities, the and or compound inequalities. We'll start with and inequalities. How many parts do and inequalities have? Do you remember? Say it. 3 parts, right? These end up being 3-part inequalities. We isolate the variable using inverse operations to all 3 parts. So here's an example. So isolate t in this and then graph it. And? Yes. So we're adding 5 to all 3 sides. Okay? Does addition change our sign? No. So keep the same inequality sign. And we end up with -1, 2t in the middle, and over here a +2. And now, Grant, what do we do to get t alone now? You divide by 2, right?
Yeah.
2. Because we're trying to leave t behind. And 2 over 2 is 1. So we have -1/2 is less than or equal to t, which is less than or equal to 1. Oh, should we have changed the signs? Why not? Positive 2 is positive. We're not dividing by negative. Okay, so now we go graph. Okay, so I have my little graph here. And I need to see 1 and -1/2. So I'm going to go 1, -1. I'm just going from -1 to 1, but I have increments of half. Okay? So what type of points do we have at -1/2 and at 1? What type of points? Solid, because of the equal sign. Solid. Oops, I went to the wrong place. It should be at -1/2 and +1. And t is greater than -1/2 and t is less than 1. Can you be greater than -1/2 and less than 1? Yes, and that's what and inequalities show us. They show us a segment, right? 2 endpoints and a segment, because the solutions are satisfying both. Compound or inequality, what do they look like? Do they have 3 parts? No, they look like what? Say it, Rachel. Two separate inequalities. So each of them need to be solved and graphed on the same graph. So here we have an example. You can pause and solve for S. Come back and show what you graph. So we have S's values less than 2 or greater than 4. And you can't be less than 2 and greater than 4. There's no number that is. So what type of dots do we put on here? Open. So we're open at 2 and less than 2, open at 4 and greater than 4. Okay, these are compound or, which end up giving us opposite rays each time. That's it for section 2. Section 3, we started to solve and graph something else. Do you remember what else we did? That's right, absolute value equations and inequalities. Still using the number line. Okay, so we're going to look at this, and you're going to need 2 panels to do it. So we have the absolute value of ax plus b equals c. So this is an absolute value equation, right? And we learned that we can end up going 2 ways with this, right? We could say ax plus b equals c, or we could say ax plus b could equal
-c.
and that's because it's in an absolute value symbol, right? So let's try this with a real world example. Wish I could extend the board. There it is. Okay. This is what you're writing right here. Okay, so Chris, what must we do with this whole entire equation first? We're solving for q, but what must we do first?
Draw your line.
No, not yet.
Add 5
Why are you doing that?
to isolate the.
That's it. Okay, we're going to isolate the absolute value. We've got to do that, and then we go 2 ways, 2 arrows. We go 2 directions. We will have to do that as well. So you're going to add 5 like you said. Oops, this is frozen. I'm sorry. So you're going to add 5, and that doesn't, well, this is an equation, right? So 3 times the absolute value of 2q plus 1 equals now 6. And then you said we would? And divide both sides by 3. When we do, boom, 3 over 3 is 1. So we have isolated the absolute value. 2q plus 1 equals 2. So now what do we do?
Do both sides.
We got 2 possible equations, right? We could have 2q plus 1 equals what? -2, or 2q plus 1 equals +2. And you write both out, okay? Some people are still trying to take shortcuts and only write 1, and you're having errors in your solutions. So, and then you simply solve. So solve and come back and check. We solved each, and we have q equals -1.5, -3/2, and q equals half. Okay? Okay, so we're down here now. The next panel, you can write this example. What happens when we have the absolute value of some expression equals -3? No solution, because the definition of absolute value is what? The positive distance from 0. You're never going to have an isolated absolute value like that equaling -3 or any negative at all. And then we had our inequalities, right? Absolute value inequalities. So we have the absolute value of some expression is less than c. So this was a little tricky because when we write the two inequalities that would be true, what does it look like? You can tell us. Christina, what does it look like? AX plus B or? Good. So she says this. One of the inequalities looks just like the original without the absolute value signs, right? And then the second inequality, AX plus B, is now greater than negative C. So we learned that if it's a less than sign, it ends up giving us what type of inequality? An and or an or? Less than. Less than. Land, and, right? Greater than, gore, or, okay? So if it starts with a less than sign, you're going to have a segment with two endpoints. And if it starts with a greater than sign, you're going to have two opposite rays, okay, with endpoints. Final thing we did was to graph and solve and graph linear inequalities. Okay, let's put the steps down to graphing a linear inequality. What do we do first? We graph the boundary line. And we've been using slope-intercept form, right? Y equals mx plus b. But instead of an equal sign, we have an inequality sign. So what does that mean for our line? Our boundary line could be dashed. And solid is the one that we always fall back on because we're used to solid lines. But if it is a less than or greater than sign and no equal under it, it is a dash line. If there is an equal sign under it, it's solid. And then we tested a point. If the point is a solution, we shade that half plane. If the test point is not a solution, we shade the opposite half plane. And I just scooted that over so that the video could see the entire. So we graph this and we're done. So I'm just going to do a quick sketch of this. And so make sure you have all of your labels, X and Y. I don't know. Okay, in this case, the first thing I notice is this is a greater than sign. What type of boundary line? Dash.
Oh.
There's no equal sign.
Oh, sorry.
Okay, I plot my y-intercept. I use my slope to find another point. I draw a dashed line. And I test a point. I can use 0, 0 as a test point because it's not on the line. So I plug that in. Is 0 greater than 0 plus 2? Is 0 greater than 2? No. My test point doesn't work, so I shade the opposite half. And that's all there is to it.